So for this example, we are going to test a hypothesis about a one sample population proportion. So from previous studies, it is concluded that the 80% of phone numbers in a certain city are unlisted. A researcher claims that the proportion is smaller than 80% and decides to survey 200 working adults. Test this researcher's claim at the alpha 0.01 significance level. Is it safe to assume that the sample size is less than 5% of all subjects in the population? Well, since our population are the number of phone numbers in a certain city, do you think a sample size of 200 is less than 5% of all phone numbers that exist in the city? So remember that one person can have up to 2 to 3 phone numbers, right? An office number, a cell phone number, or a home number. So I definitely think that 200 working adults with phone numbers is definitely less than 5% of all working adults with phone numbers in a city. To verify that this product is greater than or equal to 10, remember what that tells us. So remember the first one always claims if your sample size is less than 5% of all the subjects in the population, it implies that we have samples that are independent. And so this next one will be that our data come from a population that's approximately normal. So we have a sample size of 200 and a population proportion claimed that's 80%. So let's go ahead and use our graphing calculator and compute that really quick. So 200 times 0.8 times 1 minus 0.8. So that's 32. And 32 is definitely larger than 10, and so we're good to go. So the null and alternative hypothesis, remember the null is status quo, so it should be always, it'll be a population proportion because it says it right here, proportion. So we're just looking at the p's. So it would be p equal 0.8, or the researcher that claims that the proportion is smaller than 80%. So the alternative should be smaller, meaning less than. So it should be this first one. Now, notice that the null is greater than or equal to only because it's status quo. It's either going to be less than the 80% or otherwise more than status quo, right? And so that means the test would be, because it's less than, the test is left-tailed. And based on a sample of 200 people, they found that 76% of phone numbers in a certain city are unlisted. And so what is that test statistic? When we're doing a population proportion, recall that we actually use a z-score. So we're going to have to pick z. We only use t when we're doing testing about a mean. So z will be equal to, and then at this point, this is when we start testing, right? We start testing the claim. So let's go ahead and go to our calculator and hit stat and go to test. This is a one sample proportion, so I'm going to go ahead down and select a one proportion test, which is 5. And my null hypothesis, my population proportion would be 0.8. And my x would be the 76% of 200. So that'll be 0.76 times 200. Enter. And it calculates it for you, which is really nice. The number in the sample is 200, and I'm looking at a left tail test. So let me move the cursor over, enter, and then hit calculate. So my z-score here, if I round to 2 decimal places, is negative 1.41, and the p-value, which is rounded to 4 decimal places, is 0.0786. And so because the p-value that's being tested at the 0.01 significance level is larger than, so 0.07 is larger than, we do not reject the null, and therefore there's not enough evidence to support the claim. So the claim was that the population proportion was less than, right? So there's not sufficient evidence that the proportion of people whose phone numbers are small is smaller than the 80%. Okay, and then if we just check our answers, we'll see that we got credit on all of them were correct.